Right. Good morning, my dear students. Right. Till now, uh, all the lectures that I have covered are, dealing with the circular geometry. Now, let us proceed to the parabolic geometry. How you are able to solve the arches consisting of parabolic geometry. Right, we'll go with an example. Let us see this example. A three-hinged parabolic arch hinged at the springing and the crown has a span of 24 meters, the span AB 24 meters, and a central rise of 4 meters. Rise of 4 meters, and it carries a UDL of 30 kilonewton per meter over the left half of the span. So left half of the span from the crown to the left, you have a UDL 30 kilonewton per meter with a point load of 50 kilonewton at 18 meters from left support. From left support at 18 meters, you have a point load 50 kilonewtons, which means from right it is 6 meters. Right, what you have to calculate from this arch, calculate the bending moment, normal thrust, radial shear at a section 6 meters from left support, which means we need 6 meters, in the sense this comes to 12 meters, half of the span. Total span is 24 meters. So half of the span is 12 meters, the midpoint of it. Now this is the location where we want, let us say this is 6 meters, the midway. Okay, so this is how or what is required from the problem. So at 6 meters from left support, we want bending moment, normal thrust, and radial shear. Okay, so this is what we want. Right, let us see how do we proceed with the solution. So to start with, if you want to solve for either bending moment, maybe for, say for example, so this is the location, right, where we want all the three quantities like bending moment N and Q. So if you want bending moment at this point, so from the previous lectures, you might have understood that first what we need to solve is support reaction values. So these support reactions are necessary prior to solve for any internal forces. All these questions, whatever are being asked, are internal reactions, either bending moment or normal thrust or radial shear, are the internal reactions in the arch. So first you need to solve for these four external reactions. Then only it is possible for you to solve these internal reactions, the bending moment. Right. So how we solve the external reactions is by the regular procedure that we employed even for circular arch geometry also. So first draw free body diagram of full arch FBD of ACB. Okay, so FBD of ACB you need to consider first the full arch. So you need to apply when you have a free body diagram with you, you need to apply equilibrium equations. So you have two loads acting on it. One is UDL, another one is point load. So applying for three equilibrium equations. So for example, sigma F x 0. If you apply, so you know that there are only two horizontal forces available in this free body diagram. One is HA acting towards right, and another one is HB acting towards left, should be equal to 0. So why negative sign? Because both are opposite to each other. If one is positive, the other one will become negative. Right. So this will give you already known to you that HA should be equal to HB, and that is equal to H. So HA and HB are same in value. So that's why we go for a common notation H. So this is from the first equilibrium equation. Right, what next? Sigma F y0. Right, sum of all vertical forces equal to 0. So let us see how do you write the values required for this equation. So VA upward and VB also upward. So I take upward plus, then minus. What are all downward forces are there? So this 30 into 12. So 30 into the span is only 12 meters. And another load is directly the point load, that is 50. Total should be equal to 0. Okay. Let me now remove that extra portion that has come. So this right. So now you see sigma Fy0 is written with a notation upward forces are positive. So VA is upward, VB is upward, positive, and load from UDL is UDL into the span. That will give you total UDL value. So 30 into 12. And another point load 50 is available. So it is VA plus VB minus. So now you can simplify this. VA plus VB is equal to, now this will be 360 and 50. So total together 410. Okay. So this is the one which you will get from the second equilibrium equation. Now let us go for third equilibrium equation. That will be a moment equation. Maybe ma is equal to 0, or you can go for mb is equal to 0. So let us see sigma m b is equal to 0. Let us see that. So taking any of the directions positive, maybe clockwise or anti-clockwise. Let us see. We write say anti-clockwise a positive. Okay. Let me write anti-clockwise is positive. Right, all anti-clockwise moments are positive for me. Okay, right. So you are calculating moments about B. Let us say moments about B you are taking. So what now? VA into the distance is 24. So that we will write now. So VA into 24. Okay, that is moment from VA. So what direction it is? Clockwise. So what do you write? Negative. Because anti-clockwise is positive for me. You may choose clockwise positive according to your no, own decision is. So it's your wish to go for either clockwise positive or anti-clockwise positive. So let me go to the next force. H will pass through the point B, so H will not cause any moment. Now coming to the UDL, 30 into 12. That is a value of, so first let me write the value. 30 into 12 is the UDL value, where it will act center of this AC span. Right now, what is the distance of that load from B? It is 12 plus 6. Okay. Or else 24 minus 6. Both are same. Okay. So either 12 plus 6. This way you can calculate from right, or total minus from left. Either of that are okay. So what is the value now? Distance value 12 plus 6, 18. So this is a moment from what? UDL. What direction it is? It is going to be anti-clockwise. So what you need to write it here? Plus. Then what is the other force that can cause moment at B? It is 50 kilonewton. So load value into the distance. It is straight away available distance there 6 meters. What direction it is? Anti-clockwise minus. So that is equal to 0. So this is how you calculate VA value. This will give you VA value. Okay, let me show you what is a VA value. So this is VA value 282.5. Okay, then what about VB value? How you get it? It is simply 410 minus VA is VB. What is that value? 127.5. This is VB value. Now if you count or calculate total together, it should be 410. Now you can see vertical reaction at A is more than vertical reaction at B. Reason what? To the left of C, there is a load of 360 kilonewtons, this one. To the right of C, there is only 50 kilonewtons. So more load is towards left. That's why VA value is more. That's the logic that you have. Right. Then how you get H value? That is again you must be going for this is what you are able to solve from free body diagram of full arch. Okay, done. So you have taken full arch and you have taken three equilibrium equations and you have solved for VA value, VB value, and then you found that HA is equal to HB and it is equal to H. So now the leftover reaction is value H. How do you get it? It is from one more equation that is required because there are four unknowns and you have only used three equations. You need to use one more equation. So what is that fourth equation? Moment at C, total moment at C should be 0 because C is a internal hinge. You have a hinge here. Okay. So wherever you have a hinge, moment should be 0. That is what you are going to use. And remember, you are not taking the full arch now. It is either to the left of C or to the right of C. Either of that you have to choose. So either you choose free body diagram of AC or free body diagram of BC. It's your wish. So let us go for FBD of BC. I take BC. You take AC and work out. You should get the same value. Right. So I take the arch portion of the arch from B to C. That's all. And now take moments about this point C. So what are all the moments that you are able to get only from this portion, only from BC portion? So let us start writing. And now here you must follow the notations of positive and negative according to your beam notations, where sagging positive, hogging negative. So that must be done. So be careful with this. Writing moment at C is 0. You must take only either to the left of C or to the right of C portion, and then apply sign convention according to your sag and hog notations. Okay, let us see how it is. So VB value, you know VB value. Let us see what is VB value. 127.5. Let us take 127.5 into what is the distance from VB to C? It is 12. Now, what is the moment that it is going to create? You see, anti-clockwise. So right anti-clockwise is going to have sagging. So positive. Right. What else you have? 50. So value, moment value 50 into what is the distance between load and C? So total is 12 minus 6. So this distance is again 6. What is the value? I mean to say sign convention. So this is going to cause a clockwise moment. So right clockwise is going to give you hogging moment. So hence it is minus. Okay. Now, what is the other force left over to the right of C? The H value. So you don't know the value. So you have a notation H. H into what is the distance between C and the load? Load H is the rise value, 4 meters. And what is its sign convention? It is going to cause a clockwise moment. Okay. So again, same. 50 is also clockwise, and even h is also going to have a clockwise. Both are in the same direction. So minus. Right clockwise negative. This you know very well from the strength of materials. Okay, right. So that's all with the forces. To the right of C, you have only three forces: VB and H and 50 kilonewton equal to 0. Now you solve for H value. Even you take to the left of C, you should get the same H value. What is the H value? 307.5. Right. This is how we solve for all four external reactions. 2 here and 2 in this H. HA is equal to HB. Two values there, but the values are same, directions are opposite. Okay. Right. With this, you are having now all four external reactions. Uh, in terms of values, there are only three: VA value, VB value, and H value. Right. Now let us go for the question that is being asked. Right. Okay. So see, bending moment at 6 meters from left support you want. Bending moment 6 meters from left support. So if you want to write bending moment at this point, so what you need to have, this height is required. Why it is required? H into this height you should write for bending moment from H. So y is required. That means geometry. Same as in the case of circular arches also. When you are calculating bending moment in the circular arch, we must be able to uh, find the geometric quantity ordinate value of that point y. So there we have used a relation between Cartesian and polar. Here you don't need the polar to be used because it is not circular geometry. It's parabolic geometry. The parabolic geometry is in Cartesian coordinates. So let's see how you find y value at certain x value. So where it is, the point what you selected is at a distance of 6 meters. X is 6. So you know the geometric property of parabola. Use that. Y is equal to 4hx into L minus x by L square. So just simply substitute all the required values. H is 4 meters rise value. L is a span 24 meters. Then x value where you want y value, that is 6 meters. That will give you 3 meters is y value at a distance of 6 meters. So when x is 6, y is 3 meters. So at this point or at this section, you need to write bending moment now. Okay. Right. Let us see how you write bending moment. Here you have a value calculated already. Let us see how this has come. Right. So bending moment, I name this point as say D. So I need moment at D. Let us see how it is. Sum of all moments either to the left or to the right. So let me go for left portion. So I'm going for left of D. So what are all forces you have? You have VA value. What is VA? 282.5. So write that 282.5 into what is the distance? 6 meters between D and VA. 6. Now what is the direction? Again you need to follow sag and hog nature of directions. So it is clockwise. So left clockwise. It was earlier we used this portion which was right. So now to the left of this D. So left clockwise is positive. Okay, right. This is clockwise, so hence it is positive. Now H value. What is H value? 307. 307.5 into what is the distance? The y ordinate value. What it is calculated? It is 3. Right. What is the direction? It is anti-clockwise. So what about this left anti-clockwise? Left anti-clockwise is going to create hogging. So minus. Okay. Right. What is the next value, load value available? UDL. So first calculate what is the total load from UDL. So now what you are taking? The portion to the left of D. So that load only you have to calculate. So it is 30 into 6 is the load value, total load value. 30 into 6 is the total load value. What is the distance between D and the load? Half of that distance means 3. What is the direction? It is anti-clockwise. So this is the moment direction. About D. Okay. So we are calculating moment about D. So it is anti-clockwise. So left anti-clockwise negative. So these are all the moments that you have to the left of D. That's it. Okay. So this value is already calculated. That comes to 232.5 kilonewton meter. You can check by calculating this value with your calculators, right? So this is how we calculate bending moment at a given point. So here it is asked for 6 meters location, right? Let us see the other two questions, which is how you get n value and how you get q value. Okay, so let us see that how you get n value and how you get q value. So we have derived the relations for n and q earlier in the discussions. So what are those equations if you see just once? So this is equation for n and this is equation for q. Okay, so now we are going to use these two relations. So let me go back to the section where you want these n value and q value. Same location, 6 meters from left. Okay, so let us see or draw simply how it is going to look like. So this is a section. Okay, so let me draw this. So this is 3 meter. I mean to say 6 meters is the span location of that point D, and this is 3 meters. Maybe they are not to the scale because 6 meters much bigger, 3 meters much lesser. Don't worry. So there are reactions here. Okay, and this is point D where we want. See, this is a section perpendicular to the cross section, and you need this n value. You need this q value. Remember, these are the notations that we have used to derive these two equations. So this is what we want. So what you have with you right now? So you have, see, there is UDL acting over this portion. Let me draw that. So this is 30, I think so, 30 kilonewton meter. Let me erase that extra portion. Right, 30 kilonewton per meter. Okay, right. So this is what you have, and what is VA value? 282.5. Write it here. 282.5. What is H value? 307.5. Right. So these are all that you have. So what you are able to solve first is the H at D. Okay. And what you are able to solve for V at D. Okay. So these two you are able to solve. Now I'll just show you what exactly we have done to derive these equations. I'll quickly go back to the location where it is available. Uh, so see that I should match the directions of the V and H here, okay, and N and Q here. Okay, so Q and N directions that you will be anyhow getting with a positive value and negative value. So H that I have taken is towards left, V is taken downwards. Okay, so let me match those directions. Okay, quickly. Right, so we now, let me change that direction. Okay, now let us see. So the V direction is like this. Okay, right. So this is what we wrote as theta. So now this can be evaluated with this formula, and Q can be evaluated from this formula. Right. To get what you want in this equation, you need theta, you need V value. It is not VA or VB. Remember, it is V, that is vertical reaction at section given, or the location where you want n value. Okay, you want n value at D, so V will be V suffix D. Okay, so that is V, not it is not vertical reaction at A or vertical reaction at B. Okay, right. So how do you get V value? Sum of all vertical forces at D. Okay, so that will give you V value. H, anyhow, you have only two horizontal forces, 307.5 and HD. So if you take sum of all horizontal forces, that will give you HD value as 307.5. So H is always constant. We have learned in the introduction itself that horizontal reaction is same everywhere. So even at A or at D or at C or at B, anywhere in the arch, H is constant. So whether it is HD or something, H is constant. Right, now calculate V value. What is a vertical reaction? Now you see there are two vertical forces to the left of D. One is 282.5, another is 30 into 6. So 282.5 is vertical upward. So either you apply vertical upward positive or downward positive, whatever it is. Okay, so 282.5 upward, say minus 30 into 6, 30 into 6, and this is VD vertically downward, so downward is written minus, so minus VD is equal to 0. Right, what is VD value now? It is 180. So VD you are taking to the right, it become positive. So 282.5 minus 30 into 6, so 180. So 282.5 minus 180 is simply 182. I mean to say, let me erase that. So it is so let me write what is the value of that. Minus 180, so it is 102.5. So that it is 102.5 is VD value. So that you substitute V value here and H value here. How you get theta value? What is the angle made by this radial line with respect to vertical? That is what we want. So this line joining to the center, this is theta. So if you follow my earlier lectures, that when you derive this relation, you will know what is theta. So how you find that? It is by finding first, I mean to say dy by dx relation. That will give you tan theta value, and that will give you theta value, which is tan inverse of the value. So how you get dy by dx? You have y equation. So differentiate this with respect to x will give you dy by dx equation. So that dy by dx is nothing but tan theta from simple mathematics. So dy by dx, when you know elaborate this one, expand, no? So 4hx into L minus 4hx into x square by L square. So this simplifying, you get a simplified form like this. And now substituting 6 meters in place of x, h 4 meters, and L 24 meters. So you have tan theta value by substituting with all h, x, and L. Then theta is tan inverse of this value that you get a number. So that theta is 18.435 degree. So that theta you have to substitute into this equation. Okay, so now if you want n value, so it is simply V means 102.5 right, sine theta. What is theta value? 18.435 degree. Sine 18.435 degree. Okay, right, plus what is h value? 307.5 into cos theta. Cos theta is again 18.435. This will give you n value that you have to calculate 3 to 4.133 kilonewton. And Q for this case it is becoming 0. Same you have to substitute here for V 102.5 cos theta cos 18.435 minus H 307.5 sin theta 18.435. So where Q is becoming 0. Okay, so this is how you are able to solve a parabolic geometry in detail. Okay, so do practice this problem, and if you have any doubts, we will have GMeet conference. Thank you so much.